It's June 2023 and I have travelled to a stunning part of Germany to meet Inakustik. And some of you will remember that I visited Inakustik about this time last year. And while I was here, I learnt about their manufacturing, their air cables and more. But I had one major regret from that visit, and that was I just didn't have enough time to really get into and learn about all of the things that I was interested in. So in this visit, I'm going to make the most of my time and we're going to get straight into power. Why is power important for a hi-fi system, and how does power quality affect the sound quality of a hi-fi system? And I know that this can be a contentious issue with some audiophiles. So I've asked Inakustik to explain it to us from a technical level, which they have, and more. So this is going to be a really interesting video, but let's just start it off with some of that stunning view of Germany.
Hi guys, I'm Holger from Inakustik Germany. I'm responsible for the product development here in-house, and today I want to talk about powering up a hi-fi system and how important the AC power for a hi-fi system is. So I thought I start at the opposite end. I start with a speaker, because all what we hear, all the music, all the details and everything has to be generated from the speaker. And the speaker, as you know, the membrane is moving in and out and is building a sound pressure and has to deliver all the different frequencies, a huge mixture of frequencies, a huge mixture of different levels, really precisely for the amplifier, for the preamplifier, for the DAC, for the streaming player, whatever. It's always the same situation. They all have to convert the AC mains to the audio signal. The reality is that we are all connected in the power grid. So that means my house, the neighbor's house, the factory next to, all is connected by the power grid, and all the electric equipment we have, like refrigerators, like the power car charger, like the mobile phone charger. Everything is building a distortion on the power grid and is distributed by the power grid to all the other equipment and also to my hi-fi equipment. So that means the mains we have here in reality is not perfect. We don't have this 230 volt 50 hertz only. We also have this interference on it. We have this high frequency distortions on it. So the power supply inside the equipment can of course cut some of these distortions, but not all of them. So, and all the rest we have on the grid enters my equipment and also enters also the audio signal, and so is also deforming the audio signal. And this deformation, so we can go back to the speaker, this deformation of the audio signal will affect the final result, what we can hear.
My name is Marius Ingold, and I work also like Holger in the product development here in Inakustik. And we are now talking about the AC part and the DC part and how the AC part affects the DC part. To hear music, we must now come from this signal to this signal. And here for that, to get this signal, we have a rectifier. And first in the rectifier, we have a transformer with a primary coil, and we have on the transformer a secondary coil. We have then our our electronic, maybe our amplifier here, like that one. And then we can modulate our music and hear our music. The opinion, or the most opinion, is that we have here in the transformer, we have no connection, no electricity connection from the AC part to the DC part. But this is not the case in reality. So in reality, we have a connection. So we have this coupling capacitance from the AC side to the DC side. So the reality looks like this. So now we have from the primary side, the AC side, with the coupling capacities, we have a connection to the DC side. And the problem for that is now that the disturbances or the interference we get from the power grid, this interference are on the signal. And this interference, this high frequency distortion can go now through the coupling capacitance through the DC part. And so we have this problem that the coupling capacitance have a low resistance to the high frequencies, and so it's very easy for the high frequency interference to go from AC side to DC side. And this interference will now affect our music signal like a whale, and we get not the best result in our HiFi system. In a perfect world, the sinus wave in the power grid would look like this. So if we look at the zero position, so the positive wave and the negative wave has the same value and the same size. But the problem is many devices are working only with one wave, not with both waves, only with one wave. And then the sinus wave is not used symmetrically, so we get with this problem a DC component inside. So if we have devices they use only the positive wave, then we get an DC offset and DC component in the AC power. And now the new AC power looks like that. So you see the positive wave is now bigger than the negative wave. And so we get, or we have in reality, a DC component in the power grid. And this DC component is a problem because in our HiFi system we work very often with transformers. And this DC component will drive the transformer into a magnetical saturation. And in this magnetical saturation we get more interference through the transformer.
Okay guys, what we have here is a standard CD player, nothing special, it's from the hook somewhere, and we have of course the main power, and we have the output sockets here, which is RCR, which are RCR sockets. And you may know that this outer ring here is the ground of the audio signal. And usually the ground of the audio signal should be really stable and no voltage on it. So, if I measure the voltage we have here on the audio ground, I have here a standard multimeter which you can buy somewhere in whatever shop. I put it to measure AC voltage, and what I do now is I connect one end to the ground contact of the Schuko socket here, and the other end I connect to the ground of the audio signal, and that should be more or less zero voltage. And as you can see, there's nearly zero voltage on it. And Most of the people think that the primary side has no electrical connection to the secondary side. That means if I connect the mains to the power socket, there should also be no additional voltage here on the audio ground. So let's do it. So I connect the AC to the power socket, and then I measure the voltage of the audio ground. So once again, so here we go, and what you can see, we have, yes, nearly 11 volt as a voltage level. That means, as Marius explained before, yes, we have an electrical connection between the primary and the secondary side of the power supply, which is built in the CD player. Okay, let's take a look what happens if we connect different HiFi equipment. Here we have the CD player from the last test. Here we have a standard AV amplifier, so here we have the audio output of the CD player again, and here we have the inputs of the AV amplifier. And so as you remember, the audio ground is here on the ring outer ring of the RCR connectors. The same is here on the amplifier. And as you remember, usually the ground should be on a stable 0 level. What I do now is I like to measure the voltage difference between the CD player. So I connect the standard multimeter to the CD player, one end, and the other end I connect to the audio ground of the AV amplifier. It's just an AV amplifier because I have it here in the laboratory. It doesn't matter. It's all the same on other equipments, so you can test it at home. You see there is nearly no voltage difference we see here. What I do now is I connect the amplifier and the CD player to the mains, and then we see what happens if we do it. So I start with the amplifier. Oh, you see it's very high voltage. Okay, so we have now we have 22 volts. So that means the audio ground is on a different level. Now I connect also the CD player. It drops a little bit down. It's in Germany. It depends also on the position of the socket. Anyway, so you see we have a high voltage between the audio ground of the CD player and the audio ground of the AV amplifier. So by the way, for the people who doesn't believe it, so I go here to the audio ground of CD. So, and you see it's the same. So it's just here much easier to connect. So it's the same. So what happens if we connect an audio cable here? So we have a voltage level here between the two audio ground parts, and if we connect an audio cable here, we automatically have a current on the ground, and this current contains also all the interferences, all the high frequencies which comes from the mains. And these interferences, these distortions due to the current here is automatically added to the audio signal and puts the distortion on the audio signal. And of course, as we learned before, finally you can hear it because the distortions we add to the audio signal will pass the amplifier, will reach the speaker, and we can directly hear it.
We told about the problems we have with the power grids, that we have their interference and that we are all connected together. And to solve this problem, we have here our new product, the AC 4500. It's a power station who solved these problems. We have developed, designed completely in-house. We also assembled in-house, and we get the components like the PCB boards or the front panel, the mechanics. We get it here from a local area in Germany. Also for different countries with different sockets. For example, we have here the US sockets, the UK sockets, and also for the Europeans, the Shuku sockets. We talked about the two problems. So we have the problem that we have an DC component in our power grid, and we have interference and distortion in the power grid. And so we need a solution for these two problems. And the first solution is our DC suppressor. So in every power station we have a DC filter. So we start in the input socket with a DC filter, and with this filter boards we filter out the DC components in our power grid. And so we get a solution that we can symmetrically distribution the power. So the positive wave and the negative wave has the same size, and so every connected device on the power station are then symmetrically connected to the power grid, and we have not a problem that we have a higher wave on the sinus wave. We talked about the interference and distortion in the power grid, so we have to filter out the high frequencies in the net, and for this we have two output filter boards. Now the question is why we have two filter boards. The reason is we have different HiFi devices. So we have analog devices and we have digital devices, and for this reason every device needs his own filter board, because the filter and the connected device build in unity, and we want to get the optimization of this unity. Many measurements and tests has shown that we need for analog devices we need filter type 1, and for digital devices we need filter board type 2. And these filter circuits are different because we have not only interference from the power grid, we have also the problem that we get interference from the connected device. And so we have we have a device maybe that creates interference only in this frequency spectrum, and a digital device creates also maybe interference in another frequency spectrum. And so the digital filter and the analog filters filters the frequencies in a different spectrum. Our filter circuits are specially designed for low resistance, so you can these filter boards use for source components, also for amplifiers and also for AV receivers. For example, our advice is you use for your Class D amplifier, you can use our digital board, also for the source components. But if you have maybe a tube amplifier or an preamplifier, then you can use our analog filter boards to get the best solution. A big advantage of our new power station is that we can build and specify power station to the customer needs. So for example, here we have a customer with an DC filter and 3 filter boards from the type 1 and 3 filter boards to the filter type 2. Also with many filters inside, or you get an interference from a connected device, then you have an advantage because this interference will also be in this chamber and cannot spring into another chamber. And so the advantage is if you have an interference or a distortion from a connected device, this this distortion or this interference cannot go through a device who is connected on the socket 3, for example. And so you see with this modularity we have also an protection or an shielding from chamber to chamber, and so the interference is only in one chamber and cannot go through another device.
Another very important feature of the power station is the power distribution themselves. As you may know, the power distribution should have no resistance in the best case, but that's not realistic. But what we have done to have extremely low resistance is we use this huge power bars for the power distribution. Each power bar has a cross section of about 30 square millimeters, which is about 2 gauge, and we use this high current connectors to the PCB board, which are connected with these screws with a particular force, the torsion force for each screw. The PCB boards themselves, the copper coating of the PCB boards is 2 times higher than of a regular PCB boards. So these are some of the parts we take care of to have really low resistance for the power distribution. And to ensure that the protective wire, so the ground wire, has a really good contact to each metal part, we have these blank areas you can see here. On each metal part we have these blank areas, and also on the main plate of the housing we have these blank parts. So this ensures that each chamber has a proper contact to the grounding. This is necessary on one hand for the safety, on the other hand we need a huge connection surface also for the shielding, so that we really remove all the high frequencies, all the interferences which comes through to the housing. After the power station is built, we go here for the safety tests. That means each power station is individually tested, where the workers test for example, the ground resistance. So on very high current we test the insulation resistance, we make some high voltage tests. If the test is done and there's no fault, the equipment is storing all the results, it's combining it with a serial number, and all the results are also stored on the server, and we also have a hard copy of it to ensure that all unit we sell, all unit which is leaving our company, is really in good and perfect condition. One of the questions we get very often is what should I buy first, a power station or a power cable? Due to the fact that you already have power cables, it is wise to buy a power station first, because this power station really takes away the DC part of the mains. It takes away all the distortions. It has really extremely fast power distribution, and this is very important. It really acts for all the equipment you connect to. So if you just buy one power cable, you just improve one equipment. So that's the reason why you should start with a power station, and then you can go ahead step by step with the power cables. The next question we very often get is, if I decide to buy a better power cable for one unit, which unit should I support with a better power cable? For my opinion, it should be the amplifier. Why? It's because the amplifier has the highest power consumption. We have these current peaks on the power cables. We have really high interferences which coming from the power cable and affects the equipment around it. So if you take a good power cable with a shielding, you avoid this problem. The next thing is, if you put a better power cable to the amplifier, it will affect the whole system. So it doesn't matter if you listen to your records, or if you listen to a streaming player, or listen to a CD player, whatever. Everything has to pass the amplifier. So you increase the sound of the whole system and by changing one cable. What you're doing with a power station, you build a kind of stable island where you put all your equipment on. The power differences of the equipment is very low. So this is really a stable island for your HiFi system. To have a more stable island, it makes sense to have also a high power cable from the AC socket to the power station. The reason is the same. So we need a very fast power transmission on one hand. On the next is we have this high current peaks on the mains cable as well, and the mains cable would also act like an antenna, and we have these interferences which really affects all the equipment around the power cable. Important for the power cables is that they have a really high performance and they can really transmit the current very fast to support the equipment. The cable should be, on an electrical point of view, it should be as short as possible, and this structure helps to keep this cable electrical wise very short, so that we don't have any interferences or level differences between the equipment, and that we don't have any additional current between the signal cables or on the signal cables which are coming from the interferences.
So it's the end of my trip here to Inakustik. I've been here for about 2 days, and I think, you know, the video will speak for itself in terms of Inakustik as a company, in terms of their manufacturing quality, in terms of how everything is handmade here in Germany. And I think the way they design products and the way they explain the products and just the way everything's put together, you'll see in the video, it's extremely impressive. And I think the most impressive thing for me is the attention to detail throughout the manufacturing process, throughout the design process, and the fact they're trying to think about things maybe a little bit differently, maybe to some other manufacturers in terms of their product designs. And off camera, I've had some really interesting chats with the guys, been asking them loads of questions about power, about how things work. And that's been really, you know, interesting to me, and I've got a lot out of that. But really, it's all about the sound, right? So I've just had a couple of hours listening, you know, in here to the system that you can kind of see there behind me. We did a listening comparison and listening test between all power products from Inakustik, the Power Station 4500 and their power cables, versus a 3B strip that everybody gets, and obviously 3B types of power cables. And the difference is massive, absolutely massive. I don't want to go into too much detail, but the system you can see there behind me, it sounds very spacious, it sounds very precise, it sounds very organized. The soundstage depth and width and height and the energy and the immediacy of the system is really, really impressive. And when you take the Inakustik power products away, you lose a lot of that, the real kind of crispness of the sound. You just kind of lose that, and the sound becomes very congested together, a bit thicker, just kind of tense. There's a lot of tension in the sound, whereas we put the power products back in, all that tension goes away. The system retains that really lovely organization. So those are the things that really, I suppose, stood out to me about the Power products, they help to bring more clarity to the system, more organization, more spaciousness, and more definition, more, I suppose you could call it resolution. That's what I've heard from the couple of hours that I've spent here today. And I think just to throw in something else, we did a listening comparison between the air cables, the copper-based air cables, and the all solid silver based, I think pure silver based cables, and there was a really interesting difference between those as well. Obviously the all silver is very expensive, but you can hear that again, that extra clarity, the extra resolution, the extra energy. Like, it sounds just a bit more alive. There's a bit more of that immediacy, the timing, the speed, the quickness of more like what you expect to hear from live music. So of course, you know, it's just a couple of hours in an unfamiliar listening situation, in an unfamiliar room, with some of my own music. So the music was familiar, but you know, we listened for a whole variety of different stuff, and we used Alicia keys for the sound comparison. So nothing audiophile, nothing special really, just a general run-of-the-mill song streamed through, I think through Cobuzz, through Roon, again playing through an all Primaire system. So it's a very, very nice hi-fi system, but you know, nothing too extreme. So I just want to close out the video with a huge thank you to Inakustik for allowing me to come out and see them a second time. A huge thank you to Marius and Holger for coming on the video, coming on camera and making this video what it is. A huge thank you to all the people that work in production for allowing me to film them. And of course, all this video can really do is encourage you to go and experiment for yourself, go and try these products for yourself. And I think if you live in Germany or similar types of countries, then Inakustik will loan you products directly to you in order for you to try these out for yourself. But I'm sure throughout the world, dealers will allow you to do that, or you can either go into a dealership, or maybe they'll ship them to you to try these things out at home, because really it's all about listening. You have to listen to them, you have to try them for yourself to really, I think, know whether there's a difference there, and whether that difference is exactly what you're looking for. Do you want more clarity? Do you want more resolution? Do you want more openness? Do you want more spaciousness? Do you want more definition and resolution? I think if those are things that you're looking for your system, well, then that's what it seems like all the Inakustik products, but definitely the Power products, that's what they seem to do to me from my time here. So I've really enjoyed it. Can't thank the Inakustik guys enough. Hope you've enjoyed the video. Please hit the thumbs up if you have, and of course subscribe to the Pursuit of Perfect System YouTube channel if you'd like to see more videos like this.